Today we are going to see string matching using finite automata. So for this I am going to consider as usual two inputs. The first input is going to be the text, the second input is going to be the pattern. So pattern is the search character which we are going to make use of it for matching in the actual text. So the text which we are going to consider is AB, 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 AC, AB and A, and the corresponding pattern is AB, AB, AC, A. So this is going to be the text and the pattern which I am going to make use of it for performing the string matching using the finite automata. So for this I am going to follow three major steps. So the first step is constructing the transition table. So this table will show you how exactly the character is getting transformed from one position to another position. So the second step which is pending is going to be the transition diagram. So wherein based on the table I am going to construct the automata, and the last step is going to be pattern matching. So first we are going to start with the transition table. So the very first step for the transition table is to count the number of characters which is present in the pattern. So 1, 2, 3, 4, 5, 6 and 7. So since 7 characters are there, so the total number of states is equal to 8. So plus one number of state I am going to have, so 7 plus 1, so this 1 is going to be the final state or the accepting state. So whatever be the length of the pattern, have one character or one state more than that, then that will be deciding the total number of states which is present in a transition table. So I'm going to construct a table. So the first column is going to be the state, where I am going to have the numbers for all these 8 states, and the upcoming columns are represented based on whatever character is present in the text and pattern. So even though I have varied number of characters present in the text and the pattern, so mostly it is around the characters A, B and C. Even though it is in different order, but anyway it is A, B and C. So write those three characters over here. So A, B and C, and the entire text and the pattern is dependent on these characters only, which is A, B and C. And the last column which I am going to make use of it is going to be the pattern which the particular state is going to accept at a iteration. So these are the columns which is decided based on the input whatever is given to us. So after this is over, I'm going to define the states. So totally I need to have 8 states. So I'm going to start with 0, 0, 1, 2, 3, 4, 5, 6 and 7. So the last state is going to be 7 because we are going to start with 0. So the total number of states is equal to 8. So this is how I am going to design the row numbering. So the next step what I am going to do over here is I am going to fill in the last column. So the last column is nothing but whatever pattern is given to us, I am just going to write the pattern in the same order in the last column. So the first character in the pattern is A, so A is written first. The second character is B, B is written next. So A, B, A, C and A. So finally I don't have any character because this is going to be the final state for me, so I am not going to add any characters here. So whatever pattern was given to me, I am just going to add it at the end of the table. So now what it means over here is state 0 is accepting the character A and where it is going to. State 0 after accepting B, where it is going to. State 0 after accepting C, where it is going to. This is what is the meaning of each cell in this particular loop. Similarly, if I am just considering this particular entry, it means that state 5 acts after accepting A, where it is going to. So I am just going to check each and every character and I am going to fill in the table. So the first character which my automata is going to accept is going to be the pattern A. So pattern A is going to have number 1. So I'm just going to use this notation, the circle notation, to indicate that that particular character is accepted at this iteration. It is a continuous numbering. So this 1, it means that 0, it is accepting the character A and it is going to state 1. So the next character is going to be B. Similarly, for state 1, after accepting B, it is going to state 2. It is a continuous numbering. So 1, 2, 3, 4, 5, 6 and 7. It goes on like that. Till 7 I have to do the numbering. So 0 is accepting A and going to state 1. 1 it is accepting B and it is going to state 2. So the next character is again A. So near to A's column I have to write the next number 3. Next it is 4. So 4 I have to write it under B. Next it is A. So write the corresponding. Each row will be having only one entry. So 4 accepting A, it is going to 5. So 5 it accepts C, so it is going to state 6. And state 6 it is accepting A and it is going to state 7. So I'm just going to have a number here. So this is the end of the sequence of operations that needs to be performed for accepting the pattern. So now I need to fill in the remaining values. So how to fill in the remaining values is the first entry I'm going to take in. So the remaining entries are filled based on the concept of LPS, the longest prefix, which is also a suffix. So this we already saw in the KMP string matching algorithm, how to calculate the LPS of a pattern. That same logic I am going to make use of it for filling the remaining entries of the table. So the first unknown entry for me is state 0 after accepting B, where it is going. So since this is going to be the starting state and we know that only A is accepted, B and C is not accepted, so it means that the LPS value I am going to make it as 0. So only one character means prefix is I don't have any values to be compared with B and C. So LPS value is equal to 0 for the first row. So both for B as well as for C. So now coming to this unknown entry, I already know that state 0 has accepted the pattern A. So this is fixed for me. So this is for state 1. So for state 1, I already know that this pattern is accepted, so that is a constant value for me that I have added over here. The second entry is going to be A. So state 1 means two substring I am going to have. One is A from the previous row, another one is A from the current column. So if AA is the input for me for LPS, so LPS value is equal to 1. So why 1? Prefix is A and the suffix is also equal to A. So the substring is of length 1. So the LPS value is equal to 1. Similarly, when I want to fill in this particular entry, the first character is a constant, which is A, whereas the second character is going to be C, so AC. So AC means prefix is A and the suffix is going to be C. I don't have any overlapping character over here. So here again the LPS value is equal to 0. Similarly, I have to fill in the remaining values. So when you look into this particular entry, so here first two values are fixed, the third character alone is changing. So first two characters, it's A, B. So when it comes to this particular position, it is corresponding column name is going to be B. So ABB is the input for me. So for this I have to calculate the LPS. LPS of ABB is, initially it is AB, second time it is AB and BB. So I don't have any overlapping characters. So the corresponding LPS value is equal to 0. So when it comes to this position, A and B is fixed. Third character alone it is going to change. So this becomes ABC. So AC is compared first, AB and BC is compared next. I don't have any overlapping substring over here. So for this also the LPS value is equal to 0. So now when it comes to this position, the first three characters are constant values for me. So I'm going to fill in the remaining LPS value. So this character, the first three characters are constant. So A, B, A is constant. Now the last character is going to be A. So for this I have to calculate LPS. So LPS is AA, AB, AA, ABA and BAA. So here alone it is matching, so the length is equal to 1. So for this it is 0, for this is also 0. So the maximum among all these things I have to take in. So 1 is going to be the corresponding LPS. Similarly, LPS of C I will be calculating, which is equal to 0. So when it comes to this particular state, first 4 values are constant for me. So AB, AB, B is the string which will be accepted here. So for this the LPS value is equal to 0, and similarly for the next position also it is equal to 0. For this number 5, the first 5 characters are constant. So AB, AB, A is a constant, and I have another A over here. The LPS of this particular combination is equal to 1, and for the next string, which is AB, AB, AB. So for this, if I am going to calculate the LPS, so initially it is AB, second character it is AB, AB, third character is ABA, BAB, and fourth character is AB, 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 and the fifth combination is AB, ABA, BA, BA, B. So we won't get any other combination other than this. So the length is 0, the length is 2, because both the characters are matching. So the length is 0, here the length is 4, and here I don't have anything in common, so this is 0. So the maximum among all these things is equal to 4. So 4 is the corresponding LPS. And for number 6 it is again 0 and 0, and for number 7 all the 7 characters in the pattern are fixed. So it means AB, AB, AC, A, A. So for this position it is AB, AB, AC, A, A. So if I am going to calculate the LPS, this is equal to 1, this is equal to 2, and this is equal to 0. I don't have nothing over here. So this is how I need to construct the transition table. So the second step is, based on this transition table, I'm going to construct the transition figure. So if I look into the states, totally I have 8 states ranging from 0 to 7, and 7 is going to be the final state. So we'll draw the transition diagram. So I have state 0, state 1, state 2, state 3, state 4, state 5, state 6, and state 7. So 7 is going to be the final state, so we use the double circle notation to indicate that this is going to be the final state. Alright, so now I'm going to parallelly compare the table as well as the diagram. So coming to the previous figure, state 0, it is accepting A and it is going to state 1. So 0, it accepts A and it goes to state 1. So 0, it accepts A and it goes to state 1. So this is how I am going to construct my transition diagram. Similarly, state 0, it accepts B and it goes to same state 0. State 0, it accepts C and it goes to state 0. So accepts B and C and it goes to the same state. So I'm going to draw the corresponding state 0, it is accepting B, it goes to state 0. State 0, it accepts C and it goes to state 0. So that's all with state 0. Coming to state 1, it accepts A and it goes to state 1. So it is a loop again. So state 1, it accepts A and it goes to state 1. State 1, it accepts B and it goes to state 2. State 1, it accepts B and it goes to state 2. Similarly, state 1, it accepts C and it goes to state 0. So state 1, it accepts C and it goes to state 0. So it will be a little bit messy diagram only, since we have 3 arrows for each of these states. So similarly I am going to fill in till the last state. So state 2, it is accepting A and it goes to state 3. So state 2, it is accepting A and it goes to state 3. Next, state 2, it is accepting B and it goes to 0. State 2, it is accepting C and it goes to 0. So which means that it accepts B and C and it goes to state 0. Similarly, based on the table, I am going to fill in the remaining entries. State 3, it accepts A and it goes to 1. State 3, it accepts A and it goes to 1. State 3, it accepts B and it goes to 4. State 3, it accepts C and it goes to 0. State 4, it accepts A and it goes to 5. State 4, it accepts B, C and it goes to 0. So from 4 to 0. So it accepts the character BC. State 5, it accepts A and go to 1. So state 5, it accepts A and it goes to 1. State 5, it accepts B and it goes to 4. So previous state. State 5, it accepts C and it goes to 6. State 6, it accepts A and it goes to 7. State 6, it accepts B, C and goes to 0. Finally, state 7, it is accepting A and it is going to 1. State 7, it is accepting B and it is going to 2. State 7, it is accepting C and it is going to 0. So this is the end of the transition diagram. So for the corresponding a table in the previous figure, I have converted that to a transition diagram. So the last step which is pending for me is going to be the pattern matching. So I am going to check whether this particular pattern is accepted by the text by this particular automata. So the first character is A. So in my text, so currently I am at state 0. I am going to check whether it is going to state 1 by accepting A. It is yes, it is going to state 1, which means that this particular string is character is present. Next, from 1 to 2, I am going to check whether that is going to be B. Yes, 1 to 2 it is a B. Yes, that is also a match. 2 to 3, whether that is equal to A. Yes, it is equal to A. So this is also a match. 3 to 4, it is equal to B. Yes, that is also a match. Next, fifth character 4 to 5, is that a I will be checking. Yes, that is a. So that is also a match for me. Sixth character, it should be actually C. So in the pattern was AB, AB, AC, but when I look into the text, it is AB, AB, AB. So which means that 4 to 5, it should have been C, but I am getting a B over here. So which means that this is not a match for me. So I have to move by one state and I will check whether it is accepted by the upcoming states. So what we are going to do over here is that, so I know very well from the text that the sixth character is going to be B. So 4 to 5, it is going to be B. So 5, it is accepting B and it is going to state 4. So state 4, currently I am in state number 4. So B is also accepted for me. So this is currently it is B. So B is also accepted. So from state 4, so currently I am over here. So this position is where I am currently. This position is where I am currently in. So AB, AB, A is accepted. So the next character in the text is going to be B. So the next character in the text is B. So 4 to 5. the transition is B, so I'm just going to come in the reverse order. So currently I am in state 4 again. So after this, B is also accepted. Even though I am getting a mismatch over here, I am not worrying about that as of now, and I'll see whether that particular string or the pattern is present at any other point in this automata. So currently AB is over. So now from state 4 it is accepting A, so it is going to state 5. So here it is in state 5. So 5 it is accept, next character is going to be C, so 5 it is going to state 6. Next character is 7, so 7 is S7. So once I have reached the final state, it means that the pattern match is found. So what was the pattern which was given to me? AB, AC, A. So AB, these two characters were mismatched for me. So I am just going to skip these two characters. So excluding these two characters, if I take the next 7 characters, I will be getting the pattern AB, AC, A. Why I am skipping these two characters is because in between I am getting a mismatch at this particular point of time, right? So AB, A, BC was the pattern. But here I am getting a mismatch. So what I'm going to do is I'm going to move one state previously to the text. I'm going to traverse the text in the same order. I'm going to see whether at any other point of time I'm going to get the finite automata. Yes, since I have reached the final state S7, it means that it is a pattern match. So if in case the pattern is not found, means definitely we will not be going to state 7. We will be continuously revolving around the same automata again and again. So this is the end of the iteration. So this is a pattern match for me.